Hi students, we will go over our CA number 1 review here in this video. Feel free to fast forward to the problems you need help with. Number 1, Carlos saw the poster below at the mall advertising the opening day of a new video arcade. It says JoJo's Arcade grand opening, first 3 games free, 75 cents after 3 games. If Carlos has saved $9 from his allowance to spend at JoJo's Arcade, how many games could he play? Well, we know he gets 3 games for free, right? Plus whatever he can afford for $9. If each game costs 75 cents after the free ones, we can take $9, divide it by 75 cents. We can put in our calculator, and that equals 12. So that means he can pay for 12 games. He gets 3 for free, so in total he can have 15 games. So just to remind you how this bubble grid works, you can type in, or not type, you can write in the number in any of those boxes. Okay, you can go all the way to the left, all the way to the right. I like to just go from left to right. That's totally up to you. The first box is for you to put positive or negative. If you don't indicate anything here, it will default to positive. So we have a positive 15, so you write the number in the box, and then you're going to shade in the number below it. Okay, now if it's online, it's going to be something a little bit different. An equation is shown below. What is the value of x that makes the equation true? Basically, they want us to solve the equation. So let's rewrite it. 3x minus 10x plus 5 equals 5x plus 17. Okay. The very first thing we would do is distribute if we have parentheses, but we don't. So now we're going to clean up each side before we start moving terms from side to side. On the left side, I see I have like terms 3x and negative 10x. If I combine those, I get negative 7x. Bring down the plus 5 and everything else. So if I look at both sides, I've got a variable term and a constant, variable term and constant. What we want to do is move all of our variable terms to one side and then move all of our constants to the other before we do any kind of dividing. I know a lot of students like their variables on the left, so we can totally move that 5x from the right side to the left side by doing the opposite of what it already is. So it's a positive 5x, right? So the opposite of that would be to take it away, or a negative 5x. And when we write that also on the other side, we want to put it with a term that's like it that also has an x. So on the right it goes away. On the left we've got negative 7x minus 5x, and that makes negative 12x. Bring down the plus 5 equals 17. So now all of our x terms are on the left. We need to get both of these constants on the right. So we need to move that 5 over. Since it's a positive 5 or plus 5, we're going to subtract it from both sides. So on the left, now we have negative 12x equals, on the right, 17 minus 5 is 12. And then the very last step, if you have a number in front of your variable, you're going to divide both sides by that number. If your number was under the variable, you would multiply both sides by that number. Negative 12 divided by negative 12 is 1. 1 times x is x. On the right, 12 divided by negative 12 is negative 1. So our answer is negative 1. Now, since you have answer choices, another option you could do would be to try each answer choice or solve it and then check your answer choice. The way you would do that is you would go to your original equation, and anywhere you see the variable, you would replace it with the number that you think it is. So the way that I would rewrite this, or type it actually into my calculator, the calculator part of your calculator would be like this. 3, instead of that first x, I would put negative 1 minus 10. Instead of that second x, I would put negative 1 plus 5 equals 5. Instead of that third x, I would also put negative 1 plus 17. I would type that whole thing into my calculator, enter, And if it says true, then that means that that -1 made the equation true, and that's your solution. That's the value of x. This problem is kind of like a little puzzle. So let's read it. What I like to do with these, I like to read it sometimes, read it twice if needed. And if it's very hard to understand, you might want to start with the answer choices and see which one would satisfy what's happening in the problem. So let's see what it says. Michelle hired Acme Freight to move the furniture from her old 3-room apartment to a comparable new 3-room apartment. The kitchen had one more piece of furniture than the bedroom. The living room had 2 less than twice as many pieces of furniture as the bedroom. If the kitchen had 2 fewer pieces of furniture than the living room, how many pieces of furniture were in each of the 3 rooms? Okay, so let's take a look. Let's start with answer choice A. Okay. So it says the bedroom has 5 pieces of furniture, right? So let's see if this would work. And it says the kitchen has 6 pieces of furniture, the living room has 8. So let's go back through it. The first thing it says was the kitchen had 1 more piece of furniture than the bedroom. The kitchen has 6, the bedroom has 5. 6 is 1 more than 5, so that first sentence checks out. Second sentence, the living room had 2 less than twice as many pieces of furniture as the bedroom. Okay, the living room has 8, the bedroom has 5. 2 less than twice as many pieces. So you would twice or double the number of pieces in the bedroom, and then 2 less than that would be to take away 2. So if I twice the number in the bedroom, which is 5, 5 times 2 is 10, and then I take 2 away from 10, that's going to equal 8, which is the number in the living room. So that also works for the second sentence there. Let me erase this part. Okay. The last sentence. If the kitchen had 2 fewer pieces of furniture than the living room has 8, the kitchen has 6. 6 is 2 fewer than 8. So we kind of looked out, and A works. If you try this with the other ones, there will be things that don't work. In the actual written answer key, I wrote what doesn't work in each of these. Here's another equation that we need to solve. I'm going to rewrite it at the bottom so we can do this together. Okay, so I see some parentheses. So the very first thing that I want to do is distribute the number right outside the parentheses. So the first set of parentheses, the number is 2. We'll multiply that by 5x and by -1/3. Outside of the second set of parentheses is this 7, but there is a minus in front of it, so we're going to think of that as a -7, and we're going to distribute that to both of the terms inside. So on the left, 2 times 5x is 10x. 2 times -1/3 is -2/3. You can put that in your calculator, or you can put the 2 over 1. Multiply your numerators. 2 times 1 is 2. Multiply your denominators. 1 times 3 is 3. All right, on the right side, I've got the 24x. Just bring that down. Now let's multiply the -7. -7 times 2x is -14x. -7 times 1 is -7, or -7. Okay, so now what we're going to do is we're going to clean up each side. On the left, I've got a variable term and a constant. They can't combine. They're not like, so we're going to leave those alone. On the right, I've got 24x and -14x. Those are like terms. They both have an x, so let's put those together. 24x minus 14x is 10x, and I still have the -7. And then on the left, I've got the -2/3 and the 10x. I know some of y'all keep seeing that fraction and you're scared of it, but we're just going to keep busting through. So now I've got a variable term and a constant on each side. I need to get my variables to one side and my constants to the other. I'm going to move the 10x on the right to be on the left. So I'm going to, because it's a positive 10x, I'm going to subtract 10x from both sides. On the right, that makes 0. On the left, that makes 0. My x's have disappeared. 10x minus 10x is not x. A lot of students think that. It is 0. It is gone. So on the left, I've got -2/3 On the right, I've got negative 7, and I look at this and I say, okay, is negative 2/3 equal to negative 7? It is not. If that's not true, then that means you have no solution. There is no value of x that will make that equation true. So if I look at my answer choices, F says no real value of x will make the equation true. That's exactly what we just said. So F is your answer here. Number 5, we have another equation to solve. I rewrote it. I'm ready to go. Because I see parentheses, the first thing I'm going to do is distribute this number outside, the 2/3, to the 9x and to the negative 6. I'm going to multiply. So I can do 2/3 times 9 in my calculator, or I could put the 9 over 1 and the 6 over 1 and do it by hand. 2 times 9 is 18. 3 times 1 is 3. And 18 over 3 equals 6. If I type 2/3 times 9 in my calculator, it will give me 6. So 2/3 times 9x is 6x. Now I want to do 2/3 times negative 6. Get rid of this guy. So I multiply my numerators. First of all, positive times a negative is a negative. 2 times 6 is 12. 3 times 1 is 3. 12 divided by 3 is 4. So that's what that says. Okay, on the right, I'm just going to bring down the 4x and the positive 10. If I look at both sides, I've got a variable term, constant, variable term, constant. So I can't combine any like terms on each side, but I can move terms from one side to the other to combine like terms. So I'm going to get my 4x over to the left to be with the 6x. So to do that, because it's a positive 4x, I'm going to subtract 4x on both sides. 6x minus 4x is 2x. And then bring down my minus 4 and equals my 10. So I've got my variables on the left. Now I'm going to move my constants to the right. So I'm going to move that minus 4 over by adding it. You always want to do the opposite to both sides. Negative 4 plus 4 makes 0. So on the left I've got 2x. On the right I've got 10 plus 4, which is 14. The last step, whenever you want to get rid of the number, the coefficient in front of your x, you're going to divide both sides by that number. 2 divided by 2 is 1. 1 times x is x. 14 divided by 2 is 7. So there's the value. The answer is C. Remember how you can check that? You would go up here, you would take out this x and this x, put a 7, type the whole thing into your calculator, press enter, and it will say true. Alright, 6 is a little tricky. We have an inequality we need to solve, but the inequality isn't written numbers and symbols, it's written in a sentence. So we have to translate from a sentence, words, into numbers and symbols. Sometimes this can be straightforward, sometimes there are little parts that are a little tricky. So we're going to go piece by piece through this first sentence. 12 less than means minus. 5 times means 5 times a number. I don't know what the number is, so I'm going to call it x. Is greater than or equal to. Greater than or equal to. 6. More than is plus. Twice is 2 times. And then the number again is, I don't know, so I'm going to use x. Now, this might look like an equation so far, but there's something really important I want you to see. Whenever you see this phrase less than, whatever's in front of the word less than, or the phrase less than, is being taken away from the thing after the word less than. So I really want to have 5x minus 12. I really need to switch these two. So when I rewrite my whole inequality, it's going to look like this. 5x minus 12 on the left side. So the left side is 12 less than 5x. So I'm taking the 12 from the 5x. That can be a little tricky. Let's bring down the rest. Greater than or equal to 6 plus 2 times x is 2x. So here is our inequality. Let's go ahead and solve. Remember, with inequalities, it's a good idea to just always get your variables to the left. I don't have any parentheses. I don't need to distribute. Both sides, I have a variable term and a constant, variable term and constant, so I can't combine like terms on each side. So now I need to move my variables to the left. The 2x on the right is positive, so I'm going to subtract 2x from both sides so that it pops up on the left. as a negative 2x. 5x minus 2x is 3x. Minus 12 is greater than or equal to 6. Now I'm going to move my constants to the right, so that minus 12 I'm going to move to the right by adding 12 to both sides. So on the left I've got 3x, I've got greater than or equal, and 6 plus 12 is 18. The last step you want to do is divide by that coefficient on both sides, that coefficient of 3. Now if that 3 had been a negative, I would need to remember to flip my greater than or equal to a less than or equal symbol. But it's positive, so I don't have to do that. 3 divided by 3 is 1. 1 times x is x on the left. Bring down my greater than or equal. 18 divided by 3 is 6 on the right. So x is greater than or equal to 6. Remember, when your variable is on the left of your answer, this symbol will point in the direction that you need to shade. This is pointing to the right. If your variable was on the right side, so if I rewrote this by flipping the left and the right side, so 6 was on the left, x was on the right, I would also have to flip my symbol. In this case, notice my symbol is pointing in the opposite direction that I need to shade. So I really want to be able to see it this way. So I need to have a closed dot on 6, and it's closed because I see that equal sign. Okay, that would be this way or this way. And I need to shade to the right because that greater than symbol points to the right. So that's going to be answer choice H. And that's the only one also that even has my answer. Be careful with the symbol. All right, and number 7, we have another inequality to solve and graph. So I rewrote it. I'm ready to go. I've got parentheses, so I need to look what's right outside of the parentheses. And it's this 3 that's a negative, so I want to make sure to circle that. Okay, I think I goofed up my video for a second. Okay, so I rewrote this inequality. We're going to solve it. We have parentheses. The number right outside the parentheses is this negative 3, so I like to circle the number that I'm distributing, especially if it's negative. So it helps me to remember to multiply by that negative. Negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. Bring down your minus 8x. Bring down your greater than 21. Look at that left side. I've got lots of terms. The terms I can combine are the negative 3x and the negative 8x. Those combine to make negative 11x. Bring down the minus 12, greater than 21. I've got all my variables on the left, so I need to move my constants to the right. That would be that minus 12. The opposite of minus 12 is plus 12, so I'm going to add 12 to both sides. On the left, now I have negative 11x is greater than 21 plus 12 is 33. The very last step is to get rid of your coefficient of x. Ours is negative 11, so we're going to divide both sides by negative 11. And oh, right here, whenever you divide or multiply both sides by a negative, you've got to remember to flip your symbol. So this greater than is now going to become a less than. Negative 11 divided by negative 11 is 1, and 1 times x is x on the left. 33 divided by negative 11 is negative 3. So solution is x is less than negative 3. Now notice they have two answers with negative 3. One with the less than and one with the greater than. So if you forgot to flip your symbol, you're going to get this one wrong. My graph needs to be an open dot on negative 3. That would be right here between the negative 2 and the negative 4. So that looks like where negative 3 would be. And my arrow is pointing to the left, so that means I'm going to shade to the left. All right, here's another inequality. Remember, a lot of this test is, solving inequalities, solving equations, and then there's some functions, and that's about it. Just everything we've learned this semester. Okay, so let's go ahead and solve this inequality. I rewrote it. I see two sets of parentheses. Outside the first parentheses, I have a 3, so I'm going to distribute that. Outside of the second parentheses, I have a 2, so I'm going to distribute that. All right. On the left side of the inequality symbol, 3 times 2x is 6x. 3 times negative 1 is negative 3. Bring down your less than. On the right, 2 times 4 is 8, and 2 times 3x is 6x. Look at each side. I've got variable term, constant, those don't combine. I've got constant, variable term, those don't combine. Let's move all our variables to the left. So the variable term on the right is the 6x. It's positive, so I'm going to subtract 6x from both sides. 6x minus 6x is 0. 6x minus 6x is 0. Oh, I've seen this before. Our variables have canceled. So I've got negative 3 on the left, less than 8 on the right. So I'm going to look at this answer and say, does that make sense? Is negative 3 less than 8? Absolutely. So that means there are infinitely many solutions. So what that means is that any number that I plug into this inequality will make the left side less than the right side. Okay? Now your answer choices, the one that you would want to pick, it looks a little weird, and we haven't really focused on this, and I don't think your CA or STAR will use this notation, but this means x is an element of all real numbers. That little like cursive looking R thing, that means all real numbers are in the solution. So that's basically the same thing as saying infinitely many solutions. So this is the answer that you would want to choose. All right, number 9, rectangle ABCD has a length represented by the expression 2x minus 3 and a width represented by the expression 4x plus 1. Okay. Rectangle PQRS has a length represented by the expression x minus 1 and a width represented by the expression 3x plus 2. Which expression can be used to represent the difference in the perimeters of rectangle ABCD and rectangle PQRS? So difference, that means to subtract. That's what you get after you subtract. And what we're subtracting are the perimeters of these two rectangles. So we're taking the perimeter of ABCD and we're subtracting the perimeter of rectangle PQRS. So I'm putting these subscripts just to denote that we have two different perimeters going on here. Perimeter, remember, is when you add all the sides up. So in a rectangle, we've got 4 sides, 2 lengths, 2 widths. So let's go ahead and see if we can draw a picture of what's happening here. So we have rectangle ABCD. Its length is 2x minus 3. Its width is 4x plus 5. And then we have rectangle PQRS, whose length is x minus 1 and whose width is 3x plus 2. Okay, so let's remember how to find perimeter, okay? We're going to add up all the sides. You can either add this side is 2x minus 3, add another 2x minus 3, and then add the width of 4x plus 5, and then another 4x plus 5. Or you can say, well, I've got 2 of these lengths, 2 times whatever the length is, plus 2 of these widths, so 2 times whatever the width is. So it would look like this. 2 times our length is 2x minus 3, plus 2 times our width is 4x plus 5. So what you would want to do here is just simplify this expression, and then that'll give you the perimeter of ABCD. So let's do that first. So I see these parentheses, I'm going to distribute. Now notice here, we're not solving an equation, we're basically simplifying. So we're not moving stuff from right to left. Okay? All right, let's see what happens. 2 times 2x is 4x. 2 times negative 3 is negative 6. Plus 2 times 4x is 8x. And 2 times 5 is 10. Now we're going to combine our like terms. I've got 4x and positive 8x. And those are going to combine to make 12x. And then I also have this minus 6 and this positive 10. Those two will combine to make a positive 4. So this expression represents the perimeter of the first rectangle. So I'm going to go back up here and I'm going to write 12x plus 4. Now we're going to subtract whatever this perimeter equals. So now let's look at the other rectangle. Remember, for perimeter, we can do 2 times whatever the length is. In this case, it's x minus 1, plus 2 times whatever the width is, which in this case is 3x plus 2. So here we go. Got 2 times. For the length, it's x minus 1, plus 2 times. For the width, it's 3x plus 2. Okay, so just like before, we're going to distribute. Okay, remember, we're just simplifying here. 2 times x is 2x. 2 times negative 1 is negative 2. Plus 2 times 3x, that's plus 6x. And 2 times 2 is 4. Combine our like terms. I've got a 2x and a 6x. Those two are going to combine to make 8x. And then I also have that negative 2 and that positive 4. Those two will combine to make a positive 2. So this is the perimeter of my second rectangle. Now I'm subtracting this whole perimeter from the first perimeter. So I'm subtracting this whole thing. I've got to put it in parentheses. Now I know that some students are going to forget that. And in the process, they're going to get the wrong answer. And I guarantee they're going to have the same wrong answer as an answer choice. So since we're subtracting that whole perimeter, we've got to put it in parentheses. Now to simplify this, so I can find my answer, in front of this parentheses is a negative 1. So this is what I need to distribute to the 8x and to the 2. So we've got the 12x plus 4. And then we've got negative 1 times 8x is minus 8x. Negative 1 times 2 is minus 2. If I had forgotten to put parentheses around the 8x plus 2, the only thing that would have been subtracted would have been the 8x. The 2 would have been added rather than subtracted. See how the 2 went from a positive 2 to a minus 2. Now let's combine our like terms. 12x minus 8x makes 4x. And then I've got the positive 4 and the negative 2. That combines to make a positive 2. So this is my final perimeter. Sorry, the difference of the two perimeters, 4x plus 2, right there. Number 10, which expression is equivalent? Equivalent just means equal to this long expression here. Notice there is no equal sign. We're not solving for a value of a variable. We are simplifying, which basically means get rid of parentheses and combine like terms. So I see parentheses. So let's look at that first set of parentheses. I've got a positive 1 in front. If I multiply by a positive 1, that basically just gets rid of my parentheses. Anytime I multiply by 1, I get the same thing. So those parentheses right there are not really even necessary. We'll take them off when we go to the next line. In front of the second set of parentheses, though, is a negative 1. I definitely need to multiply that in, and we did that on the last example as well. So this will just change the sign of every term in the parentheses. Here we go. So I've got the 3.7x. Be real careful when you go to the next line that you bring down the variables, because if you don't, you're going to forget which terms are like and not, and you're going to mess yourself up. Remember, these parentheses these parentheses right here aren't even really necessary, right? So I've got a positive 0.5, and I've got a minus 6y. Then I have a plus 0.8. And then when I multiply the minus 1 into the parentheses, it's just going to change the sign of everything. So the positive 1.7x is going to become minus 1.7x. The positive 1 is going to become minus 1. And the negative or minus 2.3y is going to become positive 2.3y. Okay. No parentheses. Now we need to start combining some like terms. Let's see all the x terms. We've got 3.7x. We've got negative 1.7x. I think that's it. So 3.7x minus 1.7x equals 2x. All right, now let's look at our y terms. We've got this minus 6y and this positive 2.3y. I think those are the only ones we've got. Okay. When I combine those two guys, I need to use my calculator, make sure I combine them well. I've got a negative 6 and then a positive 2.3. So when I subtract those, take the sign of the bigger number, so it's going to be negative. And when I subtract those, I get negative 3.7y. And then the last thing to do is to combine all of those constants. And I'm going to choose a different color just so we can see it, because there's a lot of stuff going on here. We've got a positive 0.5, positive 0.8, negative 1. When I combine all those kiddos, I get a positive 0.3. So I've got my x terms, my y terms, and my constants. Okay, I can't combine any more like terms. This is my solution, and this looks like answer choice H. So I'm going to pause the video there because it's very long, and I'm going to make a second video that goes from 11 to numbers 21.